So, welcome again. So, now we are in a position to start multiple regression. So, in the previous chapter, we have learned simple linear regression. So, simple because one independent variable and one dependent variable. But in multiple regression, we need to take into account the effects of more independent variables. So more than one independent variable we are doing here. That's why it is called as a multiple regression. So the advantage of including more independent variables enables us to consider better estimates that are possible with simple linear regression. So the model is as it is, like what we did in simple. So y equal to b naught plus beta 1 x1 plus beta 2 x2 plus and so on, beta p xp plus epsilon. So beta naught, beta 1 and so on, beta p are the parameters which you need to calculate. x1, x2 and so on, xp are the independent variables, y is the dependent variable and epsilon is the error variable. So the estimated regression equation likewise is given by expectation of y is beta naught plus beta 1 x1 plus beta 2 x2 plus and so on beta p xp. So but for a population it is difficult to calculate beta, so we'll have a estimated regression equation y crown equal to b naught plus b1 x1 plus b2 x2 plus and so on bp xp. B naught, B1 and so on BP are the sample statistics which we need to compute. So the output is like this. You have a multiple regression model and a multiple regression equation. You are unable to calculate beta naught to beta p for a population, so you will draw a sample. So sample consists of data on x1, x2 and so on xp as well as on y. Then you will construct a estimated multiple regression equation in terms of B naught, B1 and so on BP. Finally, you will estimate beta naught, beta 1 and so on beta P from B naught, B1 to BP. As usual, here also we use the same concept of principle of least squares to calculate the unknowns B naught, B1 and so on BP in the sample equation. But calculating them using pen and paper is very difficult, so we use computer programming. So let us go through the question. A software firm collected data for a sample of 20 computer programs. A suggestion was made that regression analysis could be used to determine its salary was related to the years of experience and score on the firm's programmer aptitude test. So obviously salary is your dependent variable and years of experience and score are independent variables. So we are going to construct a sample or simply estimated multiple regression equation for how many sample of programmers? 20. So this is the data of a sample of 20 programmers. So experience and test score are independent variables and salary is your dependent variable. So what equation you are going to construct? For a population, it should be y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus epsilon. Because two independent variables and one dependent variable. So generally the concept is like this. You have a input data of x1, x2 and y. You have 20 items in each variable. Then we use a computer package for solving multiple regression problems. So the outputs are simple. You will get B0, B1, B2, as well as you will have coefficient of determination, sample correlation coefficient, so on and so forth. Everything you will get. So let us see how to do this. So the same data I have copied here. So yeah. So you see here we have experience is a first independent variable, test score is the second independent variable, and salary is the dependent variable. Now I'm going to run the program. So I'm selecting data, then I have data analysis, then in data analysis I'm going to regression, I'm going to OK. Then first of all, I have to give Y range. Y only one dependent variable. So I am selecting from the title to the last one. Then I have to give input range for X. Input is 2 are there, so that's why no need. You can select everything. So like that, experience test score, I am selecting everything. Yeah. So I gave everything. Then I have to select labels for the ANOVA table. Confidence intervals, you can select 95% or 99%. Then output range means where you want to give. So I'm giving a output range at 24th line. That's it. After that, I'm just running OK. Yeah, everything is done. Now I'm selecting. So you got the summary output like this. So let us see the things. So like that you have. So this is the table you are getting. So first of all, we'll only concentrate on few things, then we'll move slowly to the other ones. So the first one is for degrees of freedom for regression. Because two independent variables, so this is number of independent variables. Is 2 for the regression. Why? Because 19? 19 because, so how many observations you took? So number of observations, how many for each variable? 20. So it is 20 minus 1. This is 20 minus 1. And if you know 2 and if you know 19, obviously this must be 17. But this can also be interpreted like this. How do you interpret? How do you interpret? It is 20 number of observations minus 3. Why 3? Because for B0, B1 and B2. For this reason only we are subtracting 3. So like that you interpreted this. Then this is what? Sum of squares due to errors. So this is sum of squares due to regression. And this is sum of squares due to errors. And this is total sum of squares. Correct? Now what is this? This is mean sum of squares. What do you mean by mean sum of squares? Sum of squares due to regressions by what is its degrees of freedom? 2. And how do you get this? Sum of squares due to errors by its degrees of freedom, how much? 70. So this F and T will come again. In while. So have you understood the table at least for the initial thing? So you have total number of observations 20. We have degrees of freedom for each label: regression, residual, that is error, and total. You have sum of squares for both 3: regression, error, and total. You have mean sum of squares for 2: regression and error. That's it. Then what will be the estimated regression equation? So anyhow, these are the coefficients you got here in the down. So they are B0, B1, and B2. So you got 3.17, 1.40, and 0.25. So you got the equation as 3.17 plus 1.4 into experience plus 0.25 into score. Okay. So now, anyhow, I told you how to calculate sum of squares total, sum of squares due to regression, and sum of squares due to errors. Total sum of square means each observation minus mean whole square you have to add. Sum of squares due to errors means each observation minus estimated value whole square you have to add the sum. If you know SST and SSE, SSR can be calculated easily. So these are the things I have calculated. Now the next one is coefficient of determination. So coefficient of determination. So coefficient of determination is given by SSR by SST. That's what you have understood. So here coefficient of determination is this. So this is coefficient of determination. R. But you have an interesting observation is adjusted multiple coefficient of determination. Because in the previous simple regression also coefficient of regression formula is SSR by SST. But if you use the same here also, then you will have a problem. Why? Because in simple regression there is only one independent variable. But in multiple regression you are adding more independent variables. Then the same formula cannot be valid. So that's why we need another combination called adjusted multiple coefficient of determination. So what is the formula for adjusted multiple coefficient of determination? RA square is given by 1 minus R square into n minus 1 by n minus p minus 1. What is p? P is the number of independent variables. But no worries, because even the regression table gives the adjusted R square. This is the adjusted R square. So that value is also available in the table. That's it. So you please remember there is a relation between RA square and R square. So if I give you R square, you can calculate RA square. If I give you RA square, obviously you can calculate R square. Do you? Do you or not? Yes? Okay. Then the same assumptions what we have done for epsilon, the same assumptions which we can do here also in what? We can do it here also in multiple regression. So the same assumptions on the random variable epsilon. Like the error is a random variable with mean 0. The variance of the error is denoted by sigma square is same for all the independent variables. And the values of error are independent and the error term is normally distributed. So with these assumptions, now we are going to have two tests. In simple regression, both t-test and f-test says that is there any relationship between x and y. But here in multiple regression, t-test and f-test have different purpose. In simple linear regression, both have same purpose, but in multiple regression, both have different purpose. So why we use f-test? F-test is used to determine whether there is a significant relationship exists between y and independent variables. This is known as overall significance test. So f-test is used for overall significance. So we call f-test as overall significance test. It says that is there any relationship between y and all x's in the population. Whereas in t-test, it gives a combinations like y and x1, y and x2, y and x3. Like that, it gives the individual significance. So like the significance of y and x1 in the population, the significance of y and x2 in the population, the significance of y and x3 in the population, all those things will be dealt with. So as usual, if you are talking about f-test is overall significance. Means there is a relation between y and all independent variables or not. So null hypothesis is a positive statement. So we write that there is no relationship, which means all B1, B2 and so on BP are 0. But HA means what? One or more of the parameters is not equal to 0 means there is a relationship between y and x. So you know what? How do you calculate f? Mean square sum due to regression by MSE. So rejection rule is as usual, reject H naught if p value is less than or equal to alpha. Or you can say that the calculated f should be above the table value. How do you calculate the table value, which is based on f distribution? Numerator's degrees of freedom is regression. So we have two independent variables, so 2. And denominator is error. Error is n minus p minus 1. N means number of observations, p means two independent variables, 1. That's it. So for a given question in the exam, in the problem, so you see what is MSR by MSC. So you got MSR by MSC. So this is, what is this value? This is F equal to MSR by MS. So this is the MSR. And this is MSE. Obviously, this is what? This is the P value. So you got a P value also. So likewise, you can go for a F test for a multiple regression. So what multiple regression says, is there any relationship between independent variable and all the dependent variables? Correct? Now, t-test is also very important parallelly. What t-test is useful? It gives a pairwise relation. The relation between y and the first independent variable. The relation between y and the second independent variable. The relation between y and the third independent variable. Like that it will say about those things. Now, like here, the general hypothesis is beta I equal to 0, which means that there is no relationship between dependent variable y and the ith independent variable xi. HA means beta is non-zero, means there is a relation between y and xi. So just now in a simple linear regression we have shown what is t. So t equal to bi by standard deviation of bi. So rejection rule, you know, if reject H naught if p value is less than or equal to alpha, or it is a two-tailed test, so you know it should be between minus t alpha by 2 and t alpha by 2 for acceptance, otherwise it is reject. So how do you calculate the table value t alpha by 2? Alpha is given, so degrees of freedom must be, because of error it should be n minus p minus 1. N is the number of observations in the sample, p is the number of independent variables, 1. That's it. So if you see here, you can understand that this is the first independent variable x1 and this is the second independent variable x2. So this is b naught, b1 and b2. So if you want to go for a standard error, this is SB1 and this is SB2. Then you can calculate the test statistic T like this. How do you calculate? B1 by SB1. Similarly, you can calculate the other also. B2 by SB2. Then the corresponding P value is also given here. P value is like this. So 1.88 into 10 power minus 6 means nearly 0. So like that you can calculate standard errors for each B1, B2. You can calculate the T values for each B1, B2 and you can even calculate P value also. So showing that the significance. Yes. So now then in some cases there is a problem of categorical independent variables. So somebody may ask me whether these regressions are applied for category or not. Yes, you can apply this for categorical independent variables also is a multiple regression. So in many situations we must work with categorical independent variables such as gender, male or female, method of payment, cash, check, credit card, etc. Right? Like suppose if x2 might represent the gender, when x2 equal 0 indicates male and x2 equal to 1 indicates female. So you can represent a categorical variable also like this. So in this case, x2 is called a dummy array indicator variable. Fine. So I'll solve a problem on categorical independent variables now. I'll take a small break and the years of experience, the score on the programmer aptitude test, whether the individual has a relevant graduate degree, and the annual salary for each of the sample 20 programmers are shown on the next slide. So which means that If you read the question carefully, the annual salary is related to the graduate degree, the score on the programmer aptitude test, and the years of experience. So, years of experience, the score on the programmer's aptitude test, and graduate degree are independent. And the annual salary is dependent. But in which is the categorical variable? Graduate degree, is it having or not? So that's why the categorical data is given as the experience is my first independent variable, test score is my second independent variable, and third is the degree holding or not. So this is x1, if I take this is x2 and this is x3. So x3 is categorical variable and salary is your dependent variable. Now we have three independent variables and one dependent variable. So you have a multiple regression. Now what is the sample size we have taken? 20 observations. So we'll have this one. So this is the data I'm having. Experience is my first independent variable. Test score is my second independent variable. In degree, I have to write quantitatively. For no, I'm writing 0, and for S, I'm writing 1. And this is my dependent variable. So if you apply the Excel regression program, so we have a summary output like this. Now, what is the equation you are going to estimate? So the estimated regression equation is given by y crown equal to b naught plus b1 x1 plus b2 x2 plus b3 x3. So y crown is the annual salary, x1 years of experience, x2 score on programmer aptitude test, and x3 is the dummy variable, 0 if does not have a degree and 1 if have a degree. So then this is the output. Yeah, somebody has asked me, yes, this multiple correlation coefficient concept we don't have so far. Yeah, this maybe I feel it's multiple correlation coefficient. This concept we don't have so far. We don't have. Let us deal it in detail later. So this is R square. This is RA square. And this is N. and this is the degrees of freedom. So number of independent variables, of course, this is P equal to 3. This is total number of observations N minus 1, that is 19. And this is, of course, you can calculate from the table, but this is N minus P minus 1. 3 plus 16 is 19. So you know this is sum of squares. This is sum of squares due to regression. And this is sum of squares due to error. You should always remember that it is summing all y's minus its approximate value square. And this is total sum of squares. SST is always given by summing all squares of the differences between y and y bar. So this is SSR, this is SSC, and this is SST. So what is this? This is MSR. How do you calculate MSR? MSR is nothing but SSR by the degrees of freedom is 3. And this is MSE. MSE is nothing but SSE by degrees of freedom 16. Correct? Now the next one is F test. Why we use F test? F test we want to use to test is there any relation between y and all independent variables together. This is known as the overall significance test. So this value can be calculated as MSR by MSE. And this is the P value. So P value is coming out to be 0. So it's a significant one. Next, coming to these, this is B0, B1, B2 and B3. And these are the standard errors SB1, SB2 and SB3. Then you can calculate the corresponding test statistic. T equal to, for 1 it is B1 by SB1. So then these are the T values. For the corresponding T values you have P values. So these three are P values. So if you take the first value, it is coming out to be 0. So if you use a 5% level of significance, you say that reject H0. Means that there is a relation between experience and salary. If you take the second test scores, it is 0.04. If you use a 5% level of significance, you will say that there is a relation between test score and salary. But if you use a 1% level of significance, you will say that there is no relation. Similarly, if you use a degrees one, it's coming out to be 0.26. So very high. So you can say it's a dummy variable. So even you can increase the complexity by involving more than one dummy variable also. It's a dummy variable, which means that we are not going to compare that. Because we are introducing it as that. The question is like, yeah, if we are performing a t-test and if you see that yes, you are right. So if you want you can compare. Then what happens to a 0.26, which is like what we can say then, which is not which is above 0.05. So what we'll say, we'll accept H naught, yes or no? We fail to reject H naught, means we don't have enough evidence that having a degree and getting a salary are independent. That's what you can say. Now the same concept comes into the picture, the residual analysis. What do you mean by residual analysis? I have told you it is a graph against. So in this way you will write x-axis and the y column is a residual. So how the residuals are behaving. So what do you mean by residual? Residual is nothing but error. So error is given by the observed value of y minus the estimated value. But not only for a residual, you can have a standardized residual. But standardized residual is very difficult to calculate. Why? Because for each ith observation, residual is yi minus yi crown. But standardized residual is yi minus yi crown by standard deviation of yi minus yi crown. So if you increase the more independent variables, so you will have a very complicated regression equation, and calculating yi crown is very tough. So in such a case, calculating standard error becomes more worse. That's why we can use a computer software to calculate that. So if I use a same concept of calculating residuals, you see here we have 20 observations and the predicted salary means this is y crown and this is y minus y crown and this is yes y minus y crown. So these are difficult to calculate by a regular calculator. So if you use Excel, you will have the data very clearly. After that, if you plot against the graphs, then so I'm only concentrating on experience and test score residual plot. So this is the graph against X and residuals. This is also a graph against test score and residuals. This is the experience and residuals, and this is the test score and residuals. So that's what we have today. So far what we have discussed, I'll tell you in a briefly. So in lecture 1, 2 and 3, we discussed sampling distribution, point estimation, interval estimation and testing of hypothesis. In the next lectures, we discussed confidence interval for sigma square, and then we have 2 tests for variability. After that, we have gone for 3 different tests for chi-square. One is independence, then after that goodness of fit and comparing the proportions. Then we move to experimental design, CRD, RBD and factorial design. So in the last class and today's class, we completed simple linear regression and multiple regression. So now regarding to the problems of mid-semester examination, you just think in a way. It is very difficult to give a question on multiple regression in the mid-semester examination where we are using only pen and paper. Am I right? So what type of questions can we ask from multiple regression? Maybe I'll show you the Excel output and I'll remove some terms. That blanks you can fill. But it is also very difficult right now because it is like you have to habituate for that. So maybe probably I may not ask a question on multiple regression calculations, but still I'll tell you, if I give you an Excel output, one should understand what are the significance of each term, because I am explaining you the significance of each term in a Excel output. So if you understand the significance of each term and the formulas, if I make some blanks also, you can easily calculate. Now, regarding simple linear regression, yeah, one can easily calculate if I give you x and y values. If I give you x and y values, you can construct an equation, yes. And also for that equation, you can calculate the estimated values y crown, yes. You can calculate sum of squares due to regression, and you can calculate sum of squares due to errors, what I have explained today. And yes, you can perform a F test and you can perform a T test. Yes or no? Residuals and standardized residuals are very difficult to deal with. That may be taken as a understanding purpose. Similarly, confidence intervals and prediction intervals also you can take it as an understanding purpose. So those things I am giving only for understanding and conceptualization only. For problematic purpose, what I told you, constructing a simple linear regression equation, estimated one, calculating sum of squares, total, regression and error, calculating mean sum of squares due to regression and error, using F test and using T test. Only these things are important for examination in simple linear regression. Multiple linear regression, whole chapter is only for understanding purpose. Calculations through calculator are very difficult. If I want to give a problem on multiple regression, surely I'll give you the Excel output in the examination where I'll erase something. So in that blanks only you have to fill based on the formulas. Is it clear to you now? With respect to other chapters like sampling distribution, point estimation, confidence intervals, uh, then testing of hypothesis, confidence intervals for chi-square, and again testing of goodness of fit, testing of independence, all those things are very simple, I feel. For them, I think no need to worry about. The only worry maybe for you is experimental design problems, simple regression and multiple regression. But anyhow, if you want, I can try a problem of each kind in the next class. Yeah. So let us hope. I'm thinking that if it could be a revision, it will be nice for you. Then I will do that. I'm trying to do that. Yeah. So if everyone requires a revision of all these things in respect to, like with respect to your mid-semester examination, I will do that. So let us think, like if anyway, yeah. Yes, almost a chapter behind. That chapter, anyhow, I'm not going to ask in the mid, because that chapter again requires only a computer output rather than a calculation. So even if I teach that also, we cannot use that in the examination. So that maybe I'm not asking also. Sure, then we'll do one thing. Maybe in the next Saturday's class, I will revise each and every concept which is important for mid-semester examination, like a model one. I'll solve one question. Okay? No, no, we don't have a class on Sunday. We'll have only Saturday next time. Thank you. So have a good day today. Thank you. So if any questions, please let me know. I'll wait for you. Do you have any other questions regarding exams, regarding syllabus? Thank you. Bye.